definite integral. It's called a definite integral because...
No. I think it's IT.
NI.
Yeah, NIT.
NI, yeah.
There you go, buddy. Finite. There you go.
Yeah.
Okay.
So now we're going to talk about an indefinite integral where we don't have boundaries. Please note the difference. An indefinite integral is a function of x. A definite integral is a constant. For our purposes now.
Are A and B still 0 and 1, or?
No, there is no a and b. There's no interval. We clear on the difference?
Yeah.
So I'm going to throw down a whole bunch of different formulas to find the integral. And we will be using the antiderivative. It's called the power rule. We use it here, actually, for this one.
No.
I'm going to let you figure those out. There's a negative in there somewhere. What's the antiderivative of sine?
Negative cosine.
Negative cosine. With plus c. The antiderivative of cosine. Sine. We okay? There's one exception to this power rule. Notice what value of n do we need to avoid? Negative 1. So we need to say that n cannot equal negative 1. Yes?
Is cosine x dx equal to negative sine x?
Do one more time for me?
Antiderivative.
Is that equal to the negative sine x plus c?
No, this is regular sine. The derivatives and antiderivatives are exactly backwards from one another. So, this is if n equals negative 1, right? We can't use the power rule if n is equal to negative 1. We end up dividing by 0. What is the antiderivative, though, of 1 over x? It's natural log of x. And actually, if I was feeling better, I'd show you why, but it's actually going to be the absolute value of x, and yes, you do need to put the absolute value every time.
So from now on, you put that instead of parentheses?
When we do this integral, we end up here for sure. How we doing? What do you think that's going to be? What derivative gives you secant squared? Tangent. What are we going to get for that?
Negative.
Negative cotangent.
What was that? Cosine? What?
That's cosecant. So what's the integral of secant x tangent x dx?
Secant squared x. Cosine.
Make sure I'm not skipping any. Here's a few more. Actually, this one's important. What function, when you take the derivative of it, do you get 1 over 1 plus x squared? It's inverse tangent. We'll actually prove these next semester. Right now, you got to trouble. What's this going to be? Now, if you remember, it could be negative inverse cosine. Next semester we'll see why it could be either. There's a triangle involved. Let's make sure I'm not skipping.
What did you just say?
Yeah, we're good. Okay. Now, any variation to these, and it won't work. In fact, we'll need something else from chapter 5 to do this. Now, when I say x, it doesn't have to be x. X represents anything as we go through this. So let's start out. Here. What's the integral of dx? You can view this as doing the integral with the derivative. They kind of cancel each other out. You get x plus c. This is important that we understand. What's the integral of du in this case?
U plus C.
U plus c, right?
Are those more rules?
No?
Is that an R?
It's a gamma. What's that going to give me? Gamma plus c. The integral of d Kevin. Kevin plus c, right? Okay? Doesn't matter what that is, that's running the show. So what if I do this? All hat plus c. be running into situations like this that, and I'm going to get your brain running really high, really fast, and then you're going to forget some of these basic facts here. So I really wanted to kind of emphasize this. So that when we do hit that, we go, oh, remember when I did that thing with decaf? Right? You'll remember. When I use it, you're going to remember me doing this. So, I'm not going to say that you have to memorize these, but for sure you got to memorize these. Okay? What? There's no way around it. So, whatever you need to do, make flashcards, whatever. But these are, this is the bread and butter, this bunch here. There's lots of variations and lots of different things we're going to be doing with them, but you have to know these. All right.
No.
Here you go.
Yeah, so I would just know first.
What is the generated erasing?
I thought we were.
Theta? Yeah. So I have cosine of theta over sine squared theta, d theta. We don't have a formula for that. And unfortunately, you guys know how we have product rule? It's not just simple straight up derivative times the derivative. We've got this whole thing going on. Unfortunately, with integrals, we can't break it up. I can't break this up into the integral of cosine d theta times the integral of 1 over sine squared. I can't do that. It doesn't work that way. Whenever there's trigonometry, it's good to go back to some of the trigonometry rules that we've learned in the past.
Use of?
And so now I got to try really hard to make it match something here. What's cotangent theta over sine theta? Or cosine?
10.
Cosine theta over sine theta is cotangent.
Yes.
And whatever sine
Cosecant.
is cosine. What does that give you? A couple of places students love to skimp on the writing. I've seen students do this. Don't do this for me, guys. I'll bring a hammer, okay? Theta. Is that the same thing?
No.
You're missing thetas, you're missing the d theta, you're missing everything here. So make sure you fill the whole piece out. Especially that d theta. I'm gonna be looking for that. You okay?